All right. So for our machine experiment number 7, still will be using assembly language for this experiment, and the topic is related to arithmetic instructions. As per the program specs, of course, we're gonna be familiarizing ourselves and understand the arithmetic instructions. We'll be creating a program written in assembly language programming using arithmetic instructions and create an executable file for the program. So same sequence from the previous experiments that we did. This is short theory related to our experiment. So as we all know, arithmetic logic unit of the microprocessor is um, composing of different functions like addition, subtraction, multiplication, and division. Pero hindi siya typical na pag-add, subtract, multiply, and divide. We're now using bytes, words, or even double words. So here's the table of the arithmetic instructions. We have here the instruction and the description. So yung most of this naman ay common sa atin since we already discussed simple as possible computer. So andito yung add with carry, subtract, subtract with borrow, unsigned multiplication, sign number multiplication, unsigned division, sign number division, increment, decrement, ASCII adjust after addition, ASCII adjust before division, and so on. And then, ito na yung dalawang programming exercises that I have provided. So basically, we're gonna be creating a program that adds the 2 bytes of data and saves the result. So dito, obviously, yung values natin ay 52H and 29H. Ito yung ating code. And then, i-place lang natin siya syempre doon sa ating editor. But before natin ma-run, it's very important for us to learn yung lines of code na meron po tayo. So nakikita natin na meron tayong dot model small, which is basically a directive that specifies the memory model to be used for the program. In this case, it's the small memory model, which is typically used for small programs that fit within a single segment. We also have that stack 64, which is a directive that reserves the 64 bytes of stack space for the program. And then the data section. So ito na yung section that declares the data variables used in the program. So parang katulad lang din ng ginawa natin before. And then if we are trying to change na po the values for the data, dito yun magre-reflect. So we have your data 1 TB52H, which is a line that declares a byte size variable named data 1 and initializes it with hexadecimal value 52H. In the same way, yung data 2 naman initializes the hexadecimal value 29H for the name data 2. And then of course, since we're trying to get the summation of the two data values, meron tayong sum na variable. Sum db question mark is a line that declares a byte size variable name sum without initializing it. So it will be used to store the sum of data 1 and data 2. Then yung pang-apat na important part after nung that model, that stock, that data is yung that code natin. Siyempre, as we know, this section contains the executable instructions of the program. First off, meron tayong main proc var, which is a line that marks the beginning of the main procedure, which is declared as a var procedure. Var procedures can be called from anywhere in the program. Kaya parang ano siya, general or public procedure yung purpose ng main proc var sa high-level programming language. Then after that, we have here move AX, comma, at data, which is an instruction that moves the segment address of the data section into the AX register. And then meron ulit tayong move DS, comma, AX, which is an instruction that copies the value in the AX register, which is the segment address of the data, to the DS register, setting up the data segment register to point to the beginning of the data segment. And then next, we have here the move AL, comma, data 1, which is an instruction that moves the value of data 1, 52H into AL register. And then yung sunod naman, yung data 2, 29H naman, i-move natin yung value niya sa BL register. And then, since na-move na natin yung data ng data 1, data 2 dun sa ating registers, i-add naman natin yung values ni AL at saka ni BL registers, and then stores natin yung result niya in the AL register. So it will calculate the sum of data 1 and data 2. And then once we have that already, yung sunod natin is yung i-move na natin yung ating value ng AL register into the sum variable. Then once na move na natin yung value ni AL register dun sa ating sum na variable, sunod na yung move AH, for CH. So this instruction sets up for the AH register with the value for CH, indicating that the following interrupt 21H will terminate the program. And then we have the int 21H, which is common, which is a super interrupt invoking the DOS interrupt service routine. When AH contains the value for CH, it simply signifies program termination. Then we have the main NP, which is a line that marks the end of the main procedure. And lastly, for line 18, we have the nmain, which is a line that marks the end of the program, with main being the entry point. So basically, overall, this program simply calculates the sum of data 1 and data 2 that are being stored in the result sum variable and then terminates the program. So kapag nalatag na natin yung code natin, same procedure, emulate lang uli natin, and then run natin. Then when we press OK, so we can check the value dito sa vars. Pag kinalik mo yung vars, makita mo dyan yung value ni data 1 is 52H, data 2 is 29H, and then yung summation nila ay 70H. So yun yung ating first example. For the second example, so we're gonna create a program that simply adds the two words and then saves the results. So this time medyo mahaba yung values natin. So we have the values 2F, 52H, and then 1629H. So tingnan natin yung code natin for this. I-open ko muna yung code 72A. Alright. Ayan. So, obviously, meron na tayo dito na 24 lines of code. Katulad nung kanina, meron din tayong .model small, which is, again, a directive that specifies the memory model to be used for the program. We again make use of the .stack64, which is a directive that reserves 64 bytes of stack space for the program. And then again, data section that declares the data variables used in the program. And then dito sa loob, ganun ulit, katulad ng ginawa natin kanina. So magsiset na tayo ng values natin. So we have data 1, DW1252H, 1629H. So this line declares a word size 16-bit array named data 1 containing two elements, 1252H and 1629H. Then we have some DW question mark, which is again a word size 16-bit variable named sum na hindi natin ini-initialize ang value because it will be used to store the sum of the elements in the data 1. And then again, we have that code section. This is the fourth important part of the assembly code that contains the executable instructions of the program. Meron ulit tayong main proc var, which is the line that marks the beginning of the main procedure. Gumamit ulit tayo ng move AX, at data, which moves the segment address of the .data section into the AX register. Then meron ulit tayong move DS, AX, which copies the value in the AX register, the segment address of the .data, to the DS register. And then, again, we have move CX, 0 to each, which initializes the 6 register to 0 to each, indicating that there are 2 elements in the data 1 array. And then dito gumamit tayo ng offset. Yung move di, offset data 1, this instruction moves the offset, the memory address of the data 1 array into the di register. And then meron tayong move bx, 00h, which initializes the bx register to 00h, which will hold the running sum of the elements in data 1. And then, meron tayo ditong loop. So, meron tayong add underscore 1p, which is a label marking the beginning of a loop. Then we have add bx, comma, bracket di, which is an instruction that adds the value pointed to by di to the bx register, which is the current element of data 1, and updates the sum. Then we make use of increment. Yung increment di is an instruction that increments the di register to point to the next element in data 1. And inulit natin yung increment di1 since di1 contains word size elements. This instruction increments di again to move to the next word in the array. And then after noon, gumamit tayo ng decrement. Decrement cx, instruction that decrements the cx register, which counts the number of elements processed. And then gumamit tayo ng jump, jnz, add underscore 1p, which jumps back to the add 1p label if cx not equal to 0, meaning there are more elements to process. And then gumamit tayo ng move si, offset sum, which is an instruction that moves the offset or the memory address of the sum variable into the si register. Then move SIBX, which is an instruction that stores the final sum in the BX register into the sum variable. And then gumamit ulit tayo ng move AH for CH. Yung katulad ng kanina, we indicate the following interrupt 21H call that will terminate the program. And then in 21H again, which is a software interrupt. Now, when AH already contains the value for CH, it signifies program termination. Then main NP is the line that marks the end of the main procedure, and main is the line that marks the end of the program, with main being the entry point. So overall, this program simply calculates the sum of the elements again, but this time in the data 1 array, and then stores the result in the sum variable, then terminates. So ganun lang ulit when we emulate, and then when we run. So we can check here the value of data 1, which is 1252H, and the value of sum, which is 287BH. So, ano naman yung activity na kailangan natin gawin? So, meron lang akong dalawang main problems given. The first one is we're gonna be creating an assembly language program that is capable of computing the sum, difference, product, and quotient of 2 bytes as inputted by the user. The values of arithmetic operations must be stored in a predefined variable, katulad ng ginawa natin kanina. Pero example natin ay per summation. So, i-upgrade mo lang siya to include for the difference, product, and quotient. And then, this one is another problem. You're gonna be creating and running a program that computes for the weekly salary of an employee for the specific region. The weekly salary is computed as number of hours worked multiplied by the rate plus the overtime pay. Overtime pay can be computed as overtime hours worked multiplied by 120% of the daily rate. The name of employee, rate, hours worked, and hours rendered for overtime are all user input. So, pwedeng nakalagay na siya mismo doon sa code mo. It's okay. The specific region should be in the form of choices, at least 4 choices. And then the output will simply display the name of the employee, the salary for the month, and the region he belongs. So, for the output, again, you're gonna be providing me the assembly code, the simulation results, including the screenshot of your code, and of course the results. Pwede magkakasama naman sila, and provide the necessary conclusion.